Good day, Chem students. I am teacher Christian, and today our topic will be all about drawing of the Lewis structure. But before that, these are our objectives for today. The first one is to determine the steps and methods to use in drawing a Lewis structure. The second one will be to explain the number of covalency bonds of the elements, and the last one is to draw the Lewis structure of molecules. Now, what is a Lewis structure? A Lewis structure is a diagram that represents the arrangement of valence electrons around atoms in a molecule or ion. It is a visual way to depict the bonding between atoms and the presence of lone pairs of electrons. So basically, this is the things, the diagrams that you see in your previous classes, or in there are lines and dots in each elements. Now, first, let us look at the number of covalent bonds. This number of covalent bonds is also very important in drawing the Lewis structure. Without knowing this topic, and you cannot proceed to drawing the Lewis structure. The groups in the periodic table of elements tells you how many valence electrons there are in each element. So, in group 3A, there are 3 valence electrons on the elements that belong to this group. And for boron, it has 3 bonds, meaning that it can only form 3 bonds, and these bonds are its covalency, or number of covalent bonds that it can form. The next one is group 4A, which is of course has 4 valence electrons, and carbon 4 bonds, silicon 4 bonds. Group 5A has 5 valence electrons, and nitrogen has 3 bonds, and phosphorus has 3 bonds, but there are also some exceptions, which sometimes phosphorus can form 5 bonds. Group 6A has 6 elements, Group 6A has 6 valence electrons, and the elements that belong to this group are Group 6A has 6 valence electrons, and the elements that belong to this group are first oxygen, which can form 2 bonds, as well as sulfur that can also form 2 bonds. However, again, sulfur can sometimes form 4 to 6 bonds, because this is also an exception. Group 7A also has 7 valence electrons, and the groups here, fluorine, chlorine, bromine, and iodine, can form 1 bond. However, chlorine is an exception, bromine is an exception, and iodine is also an exception. Sometimes, chlorine can form 3 or 5 bonds, bromine can form 3 to 5 bonds as well, and iodine can form 3, 5, or 7 bonds. Now for the last group, which is group 8A, it has 8 valence electrons, meaning that the octet is already formed. And having 8 valence electrons in its outer shell means that it is also already very stable. Hence, the elements that belongs to these groups are also called noble gases. These elements are helium, neon, argon, krypton, and xenon. These elements already has a complete valence shell, therefore they cannot form any bonds. Now, let's proceed to drawing the Lewis structure. These are the general method that we can use in drawing the Lewis structure. Now, let me give you an example. H2O, or otherwise known as water, perhaps the most common or the most well-known molecular compound out there. Now, the first step in drawing the Lewis structure is to find the total number of valence electrons of all atoms in the molecule. Now, H, or hydrogen, belongs to group 1, meaning that it has 1 valence electron. And since it has 2 atoms in this molecule, then you multiply it by 2, giving us 2 electrons. Oxygen belongs to group 6, meaning that it has 6 valence electrons. And since it only has 1 atom in this molecule, then you only multiply it by 1, giving us 6. Now, total the number of electrons. 2 plus 6 equals to 8. Now for step 2. Look for the central atom, the atom with the highest covalency number in the central atom. Going back to our table, the atom or the element has the highest covalency number is oxygen, because it can form 2 bonds, whereas hydrogen can only form 1 bond. Therefore, write first the oxygen on the central and hydrogen on each side. The next step is to draw a line between each pair of connected atoms to represent the 2 electrons in a covalent bond. So, we need to draw a line. These lines also represents two electrons each, one from the oxygen and one from the hydrogen. Now, add the lone pairs so that each peripheral atom connected to the central atom gets an octet. How many electrons do we need to get? Yes, that's right, 8. And each line already has 2. So 1, 2, 3, and 4, meaning that we can only add 4 remaining electrons. Now the step says that add lone pairs to the peripheral atom, meaning here, here, and here, because these are our peripheral atoms. However, we do not add lone pairs in hydrogen because hydrogen only has 1 atom in total. Therefore, you can no longer add lone pairs or electrons to it because it is not capable of holding more than 1 electron. And so, we proceed to the next step, which is to place all remaining electrons on the central atom. So, there are 4 remaining electrons, therefore add the lone pairs here. Now, let us count the number of electrons. A line represents 2 dots or 2 electrons. So 2, 4, 5, 6, 7, 8. So the 8 electrons are now completely distributed to the molecule. Now the next step is if the central atom does not yet have an octet, after all the electrons have been assigned, take a lone pair from neighboring atom and form a multiple bond to the central atom. Now, let us count if the central atom still does not have an octet, meaning that it has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8, meaning that the octet is already complete. Therefore, this is our Lewis structure for the molecule of water. And that is how you draw the Lewis structure of molecules. For your assignment, I want you to draw the Lewis structure of the following molecules: CH4, BF3, and NH3. The PowerPoint presentation for this lesson will be uploaded to your Google Classroom as well as your assignment, so make sure to check it out. And that's it. I hope you learned how to draw the Lewis structure, class. This is a very important concept in chemistry, so make sure to study and learn it very well.